Hello everyone, welcome in channel of Mr. Statistician. Today we are solving GATE 2021 question number 39 of statistics paper. Let's get started. Let x1, x2, dash dash xn be a random sample of size n is greater than equal to 2 from a distribution having the probability density function f of x, theta equal to 1 upon theta e raised to minus x upon theta x is greater than 0, where theta belongs to 0 to infinity and x of order equal to minimum of x1, x2, xn and t equal to summation of xi, then expectation of x of order 1 given t equals to. This problem is an application of Robb-Blackwell theorem. Statement of Robb-Blackwell theorem is let u equal to u of x1, x2, xn be unbiased. Let t equal to t of x1, x2, xn be a sufficient statistic for gamma of theta. Consider a function phi of t of sufficient statistic defined as phi of t is equal to expectation of u given t, which is independent of theta. That because t is sufficient for theta, then expectation of phi of t equal to gamma of theta. Here we need to define in the problem which is a u, which is t. Here therefore here u equal to x of order 1, v equal to t equal to summation of xi, gamma of theta is equal to expectation of x of order 1. Here we need to find gamma of theta, that is expectation of x of order n. Here x1, x2, dash dash xn from exponential with 1 upon theta, that is x1, x2, dash dash xn follow IID exponential 1 upon theta. We know that the result of order statistics, if x1, x2, x1 be a random sample from exponential 1 upon theta, then x of order 1 follows exponential n upon theta. Here x1, x2, xn from exponential 1 upon theta, therefore x of order 1 upon theta follows exponential with n upon theta. Therefore expectation of x of order 1, not x of order 1 upon theta, x of order 1 follows exponential n upon theta. Therefore expectation of x of order 1 equal to theta by n, because we know if x follows exponential with 1 upon theta, then expectation of x equal to theta. Use this result. Here expectation of x of order 1 is equal to theta by n. This implies that gamma of theta is equal to theta by n. Second step, we show that the t is sufficient and complete statistics. Sufficient statistic only, not complete. See in Robb-Blackwell theorem, u is unbiased. Here we prove that u equal to x of order 1 is unbiased for theta by n, that is gamma theta. Second, we prove that t equal to summation of xi. We prove t equal to summation of xi is sufficient for gamma theta. For gamma theta is equal to theta by n. Here see that in theorem t be the sufficient statistic for gamma theta. Here prove we know that t is sufficient for theta if and only if likelihood of theta given x vector upon j of t theta is equal to h of x1, x1 to xn, that is this likelihood upon density of statistic t is independent of theta, that is it is free from theta, that is h of x1, x2, xn. It is only function of random sample, not contain parameter theta. So we prove that this here L of theta given x vector is equal to product of I equal to 1 to n f of xi comma theta is equal to product of I equal to 1 to n 1 upon theta into e raised to minus x upon theta is equal to 1 upon theta raised to n e raised to minus summation of xi upon theta. This likelihood, and we know that t equal to summation of xi follows. Here x1, x2, xn are exponential from 1 upon theta, therefore summation of xi follows gamma with parameter 1 upon theta comma n, because here random sample of size n, therefore g of t comma theta, that is density of state statistic t, is equal to 1 upon theta into e raised to minus 1 upon theta into xi, that is into t, that is equal to summation of xi into summation of xi into n minus 1 into 1 upon theta raised to n upon gamma n, that is equal to 1 upon theta raised to n e raised to minus summation xi upon theta into summation of xi raised to n minus 1 upon this gamma n equal to n minus 1 factorial. This is going to numerator, therefore g of t comma theta is equal to this. We can show that this ratio of these two densities, likelihood theta given x vector and g of t comma theta, is free from theta. Let's check. Likelihood is this is equal to 1 upon theta raised to n e raised to minus summation xi upon theta divided by n minus 1 factorial into theta raised to n into e raised to minus summation xi upon theta into summation xi raised to n minus 1. Here cancel out, equal to 1 upon n minus 1 factorial into 1 upon summation xi raised to n minus 1. Here observe that likelihood is likelihood upon distribution of statistic t is free from theta, that is does not contain parameter theta, therefore t equal to summation of xi is sufficient statistic for theta. Sufficient statistic for theta. We know that the property of sufficient statistic is t is sufficient for theta and psi of t is 1 to 1 and 1 to function of theta, then t is sufficient for psi theta. Here we check it for for gamma theta equal to theta by n. Here gamma theta is 1 to 1 and 1 to function, therefore t is equal to summation of xi is sufficient statistic for gamma theta, that is in theorem for psi theta is equal to theta by n. So here check Robb-Blackwell theorem, both conditions are satisfied. U is unbiased and T is sufficient statistic. Then we define psi T. This psi T is phi T, not psi T. Phi T equal to expectation of U given T, that is equal to expectation of, here U, I assume that U is equal to x of order 1 and T is equal to summation of xi, that it is equal to summation of xi is equal to, in this theorem, is equal to gamma of theta. Here gamma of theta is theta by n. This by Rao-Blackwell theorem. Let's check for each choice of an choice, that is for first choice A, given that in the choice A expectation of x of order 1 given t, that this is equal to t by n square. So let's check this phi t, not this theta by n. Here phi t equal to expectation of u given t is equal to expectation of x of order 1 given t. This implies that by Rao-Blackwell theorem, expectation of phi of t, that is equal to expectation of x of order 1 given t is equal to theta by n. This from statement of Rao-Blackwell theorem. Here expectation of x of order 1 given t equal to t by n square. This is assumed that phi t is this. Let's we check expectation of phi t equal to theta by n. Therefore expectation of x of order 1 given t is equal to expectation of phi t, that is equal to expectation of phi t is assumed t by n square. That's expectation equal to 1 upon n square into expectation of t. Here t equal to summation of xi, and x1 x2 xn follows exponential 1 upon theta. Therefore summation xi follows gamma with 1 upon theta comma n. Here n is number of sample or number of random samples. Therefore expectation of t equal to n of theta, because we know x follows gamma with 1 upon theta comma n. Then expectation of x is equal to n theta. Therefore here 1 upon n square, expectation of t is equal to n theta. From this n theta, therefore this is equal to theta by n. Hence by choice A, this Rao-Blackwell theorem condition is satisfied. Therefore answer is A. Here we check other conditions. These are not satisfied. You try to solve this other condition are satisfied or not.